Classifying shapes in 3rd through 5th grades means more than students simply being able to identify an octagon. I'm Allison Dowda from A Double Dose of Dowda, and in this video we are diving into what the standards require in terms of classifying polygons, quadrilaterals, and triangles in upper elementary math classrooms. First, let's take a look at the progression of classifying polygons standards. Now, you can see from 3rd to 4th to 5th grade, these are all very similar. In 3rd grade, students are expected to classify polygons and, more specifically, quadrilaterals. In 4th grade, the standards move to them doing polygons as well as right triangles. And then in 5th grade, they're continuing with classifying polygons, but they need to be able to classify all triangles. What we see happening across these standards really is that the vocabulary increases. However, I've found that when teaching 3rd grade, I still have to use a fair amount of vocabulary that isn't explicitly mentioned until 4th grade standards. We'll talk more about this in a moment. But at all levels, students are expected to classify polygons into multiple categories. And that's really what the focus becomes with these extra terms and these extra polygons, is that they should be able to identify those and classify those in more than just one way. I mentioned vocabulary, and here's a list of the terms that should explicitly be known in 3rd grade and then in 4th and 5th grades. Now, I have found I can't teach quadrilaterals in 3rd grade without first explaining right angles and parallel lines. If I'm teaching them about equal sides, why wouldn't I use the word congruent? So these are just kind of some ideas here of the words that I find necessary to include in 3rd grade, even though they may not specifically come up until the 4th grade standards. But they need to know about polygons. They need to know about open and closed figures. They need to know right angle and congruent, parallel, opposite side, and then the general classifications for polygons based on the number of sides and angles that they have. Moving to 4th and 5th grades, that's when students need to know the words perpendicular. They have to know acute angle. Again, I tend to introduce that in 3rd grade as well. But acute, obtuse, straight, and reflex angles are all included in 4th and 5th grades. Acute triangle, obtuse triangle, right triangle, just all the different types of triangles are also introduced in 4th grade. In 3rd grade, the primary focus is that students can classify shapes by the number of sides and the number of angles. In 4th grade, students must also explain how to classify polygons based on whether or not their lines are parallel or perpendicular. This is when they're first really introduced into this for classifying shapes. Their new learning in 4th grade is classifying right triangles. Now again, why would I not go ahead and teach them about acute and obtuse triangles if I'm already teaching them about those types of angles? So it just firms up the vocabulary, and they must also be able to classify right triangles by their sides, so isosceles or scalene. In 5th grade, the standard and vocabulary are primarily a review, except that now, as I mentioned in the last slide, they are classifying all triangles, not just limiting it to right triangles. Now, when it comes to instruction, as often as I can, I like to use what's called the CRA model for teaching. So the CRA model represents first the C, the concrete level. So this is when you introduce things in a hands-on way to students. They're using manipulatives. In some way or another, they are touching whatever the math is. R is for representational. And this is when we use pictures, drawings, anything that's visual. Think maybe on paper, but not necessarily. And then lastly is abstract. So this is when we just use equations or algorithms. There are no pictures, there's not a visual component. This is when students can do things with fluency and do not need any sort of manipulatives or representation. It's the highest level. So we want to make sure that we don't skip straight to abstract, that we, in every lesson, as best we can, take students through concrete and then representational before arriving at abstract. When teaching how to classify polygons with the CRA model in mind, I like to begin with Geo Boards. Then I move to pictures, and finally to the more abstract descriptions and explanations without the use of pictures. I'll show you some examples in just a minute. But for now, let's see some examples for how teaching this can look. I'm going to use this free digital Geo Board today, which is linked in the description, to show you how I would set up my introduction specifically for third graders. Now, two advantages to using this virtual manipulative if students have access to devices are that one, you don't have to spend any money on physical Geo Boards because they can be a little pricey at times, and two, you don't have to worry about any rubber bands flying across your classroom. So I start by talking to students about polygons and explaining that a polygon is any 2D shape that is closed and made up of only straight lines. And we talk about open and closed shapes. Now, in this case, to use the geoboards, as we're starting to build things, you select your band and drag it to a starting point. It automatically makes one line, and then you grab the end point and drag it down. Now, you can also grab it at a center point and drop it, and you can make shapes this way. That's how you use this digital geoboard. I like to tell students that for a shape to be closed, I tell them that every end needs a friend. So in this case, this shape is not a polygon because although this piece is closed, this end and this end, they do not have a friend. They don't go together. If we didn't have those there, it would be a polygon. But a polygon has to be a closed shape and it can only use straight lines. So we talk about a circle not being a polygon for that reason because it doesn't have all straight lines. So we do examples of different polygons and non-polygons. Next, we move through the generic names for polygons based on the number of sides and angles. We start with triangles, as you see here, and of course they are already very familiar with triangles, but I will have them make two completely different triangles, and I like to have them use different colors as well. So in this case, maybe this triangle may look like this. So two different shapes that are triangles. We work through all the different polygons this same way, all the way through decagons, and they have to make two different examples of each polygon. Going through all of these and having a practice activity for them usually takes one day. Then, on day 2, we go back to the geoboards again and focus on quadrilaterals. If you're teaching 4th and 5th grades, it's probably worth the time to review all of this as well. Still using geoboards, I talk to students about right angles, and I establish that the corner of a piece of paper is a benchmark for a right angle. I'll have them make multiple right angles on the geoboard. And they have to check them against a piece of paper, the corner of a piece of paper. Next, I have students make a yellow rectangle, and they can make whatever sort of rectangle they want to make. It can take any form as long as it's a rectangle. And I introduce the term opposite sides. So I have them take 2 blue rubber bands and show one set of opposite sides. And then they have to take 2 red rubber bands, and show me the second set of opposite sides. So once we establish that they know the term opposite sides, that helps us as we go and start creating all the different quadrilaterals on their geoboards. Again, I challenge them to come up with, for each one to come up with at least 2 ways that a shape can look. So 2 different rectangles, 2 different rhombuses or rhombi, 2 different parallelograms, whatever it is as we go through that, they have to show me 2 different ways. Then once they kind of get a grasp of things, I like to call out a specific shape for them to make on their Geo boards. And if you're using physical Geo boards, they can hold it up for you, or in this case, you can just check their screens. I might say something like, make me a quadrilateral with one pair of opposite sides. Now for 4th and 5th grades, you would then move on to introducing different types of triangles. All of this with the Geo boards is the concrete part of teaching polygons. When we move to representational, it's all about drawing the shapes. Now, abstract is when we ask students simply to classify a shape based only on a description of its attributes or vice versa, and tell us the attributes of a named shape without the picture to go along with it. So it's all just a lot of description, and if they don't have a solid foundation for these shapes, if they haven't gotten to build those and play with them, then they're probably not going to be very successful once we hit that abstract level. The major milestones that your students are responsible for learning are first that they can classify polygons by their sides and angles. Now again, what sides and angles means will be a little more advanced as they go to 4th and 5th grades, and there are more terms that they have to be able to use to classify their polygons. But the main thing is that they can first classify polygons by their sides and angles, and the second big milestone is that they can classify quadrilaterals if you're in 3rd grade, or the different types of triangles for 4th and 5th grades into multiple categories. Again, that key word is multiple. Here are some examples of what types of questions students should be able to answer. For 3rd grade, they should be able to answer questions like this: which shapes are polygons? They should be given a polygon and be able to name it based on its sides and interior angles, just based on the numbers of those. They should be given a quadrilateral specifically, and for 4th and 5th grades, this would be for different types of triangles. And they should be able to identify all the different possible ways that that shape can be classified, not just in one way. Then lastly, a couple of abstract levels. What name best describes a 10-sided polygon? This is a straight up vocabulary question in this case. Are all trapezoids parallelograms? Are all squares rhombuses or rhombi? So those are questions they should be able to answer, as well as they should be able to draw a quadrilateral that is not a trapezoid, parallelogram, square, rhombus, or rectangle. Like these sorts of higher level thinking questions should be used in your classroom, whether you're teaching 3rd, 4th, or 5th grades. But this is an abstract level of a question. Usually I move into ways that you can use intervention and enrichment to help students who are either struggling or who are doing really well. But before we get to that, I have a few quick tips specifically about teaching polygons. So tip number 1 is make sure that you are showing students figures that are in different positions. For instance, they shouldn't always think a right angle has to look like this. It can be, on its side. It can be spun around a different way. Same thing for a square. So oftentimes, for instance, in 3rd grade, students will call this a square, they will call this a rhombus. Just because it's a square on its side, that does not mean that it is a rhombus and that is the most specific name. Tip number 2 is make sure that you include irregular polygons. So for instance, in this hexagon, students are used to seeing this kind of honeycomb shape, and they can recognize it as a hexagon because it has 6 sides. But in this case, this figure also has 6 sides, but students will sometimes not be as comfortable labeling this a hexagon. So make sure that you're including not only the regular polygons, but also irregular shapes. All right, this third one is kind of a big deal, and it may be something you haven't thought about before, but you need to make sure to check your trapezoid definition. There are actually 2 different definitions. The traditional says that there is only one set of parallel lines in a trapezoid. However, there is what's called the Euclidean definition, and it says that there is at least one set of parallel lines. And in higher level maths like calculus, sometimes a trapezoid will use this definition of at least one set of parallel lines versus the definition of only one set of parallel lines. Tip number 4 is whenever you're talking about classifying anything really, but especially when we're talking about classifying polygons or quadrilaterals or triangles or whatever it is, I recommend have an analogy for those categories. For instance, I have in the PowerPoint that I use to teach, we talk about different foods, and I relate all foods to a quadrilateral. And then there are specific types of foods. There are desserts, and then there are donuts, and then there are frosted donuts, and there are filled donuts, and then there are frosted filled donuts. Can you tell I like food? So in this case, I like to have something to relate so that students know this hierarchy of classifying shapes. And this is a tool that I use frequently. I use this in combination with tip number 5, which is use an anchor chart. Make sure that your students, especially as they're learning this vocabulary, because whenever you do polygons, it's very vocabulary heavy, make sure that you have something that they can reference. So I use an anchor chart for classifying polygons. I also have one for classifying quadrilaterals. So let's talk about differentiation. If students are having trouble, if we need some intervention and some extra practice, I can just about guarantee you that it is because they need help with the vocabulary. So the first intervention is vocabulary, vocabulary, vocabulary. Use different tools so that students can practice that vocabulary so that they understand right angles, perpendicular lines, parallel lines, congruent, all of these sorts of things. Make sure that they know the vocabulary. Then secondly, make sure that they can classify quadrilaterals in one way, just one way, before moving on to 2. To challenge students, have students classify shapes in multiple ways. We want to stretch them so that it's not just one way, maybe not even just 2 ways. Maybe there are even 3 ways that some shapes can be classified. Next, students can write explanations for their classification. They would have to write out an explanation where they have to use the terms right angles, parallel lines, congruent lines, opposite sides, those sorts of things. Have them write about it. And then lastly, if they really are ready for a challenge, let's say that they are in 3rd or 4th grades, go ahead and start teaching them some more advanced vocabulary. If they know about acute and obtuse and reflex and straight angles, the terms for different types of triangles, if they're isosceles or scalene, go ahead and introduce that early, and that's fine as long as they're doing well with it. Now, in case you need it, I have linked for you in the description for the video, I have a Polygons and Quadrilaterals no prep bundle, especially focusing on 3rd grade standards because it's about polygons and quadrilaterals. Here's what all it includes. I have first a PowerPoint with not only the class notes that you would share on the board, but also student notes with blanks that they can fill in, and it also includes an exit ticket for the lesson, as well as a game that can be played as Scoot or task cards, however you would like with that. The bundle includes a worksheet for identifying polygons, as well as identifying quadrilaterals. So these are fun classification practices that students can do in a maze worksheet, and they really like those. I have 2 anchor charts for you. One is on classifying polygons, one is on classifying quadrilaterals. And it's worth noting on this that I do have full page sizes. I have half sheets available so you can print them for interactive notebooks like you see here. Or I also have them available in large sizes so they can be printed as a poster and put on your wall. I love doing that. Next, I have some activities. So these make great small group activities. These make great centers or stations, however you want to use them. I have a matching game that is specifically about classifying all the different types of polygons. You can see that they are leveled. So level 1, level 2, level 3, they get more difficult as they go. Same for a quadrilaterals task cards set. So identifying them becomes more difficult as they go along. I have a quadrilaterals tic-tac-toe. So students have to identify quadrilaterals. Again, somewhat differentiated on this one. And then lastly, a dice game where students just have to name figures, classify shapes, answer questions. Finally, I have also included a free handout for you if you want to have a piece of paper to help you remember everything that we talked about today with the progression of the standards, the different strategies for teaching vocabulary and my 5 teaching tips that I shared, as well as the milestones, intervention enrichment. Everything is here and it is linked in the description for the video as well. So that is free for you to grab. I want this to be a helpful tool that you can stick with your lesson planning notebook and be able to pull out for the next time that you teach classifying polygons or quadrilaterals. I also have a separate sheet for classifying polygons and triangles if you're a 4th and 5th grade teacher. As always, thanks for watching, and we would love for you to subscribe to our channel.